All right, we're going to look at page 10 and go over the free response on this page. So this first problem is a data collected for a relationship between height and arm span, and you are first asked to describe the relationship. Okay, so in trying to describe that relationship, what we want to do is give those things about um, the direction and the strength and what kind of shape it generally looks like, so we can see that it's kind of following this. Um, and I don't think did we know, were we told the R value? I don't think we were told the R value. So, so I would say it's a fairly strong. And then, of course, it's going in the positive direction, and it looks pretty linear. So that's the things that you're expected to say about Part A. In fact, let me show you the grading guidelines. It says, there is a moderately strong, positive, linear relationship between height and arm span. So moderately strong, positive, linear relationship between height and arm span. Okay, so now let's actually look at what they required for grading and scoring. So they said that in order to get credit, you had to say that it was approximately linear. The relationship is positive and a type of moderate to strong, and then you had to use context. So in order, you either got if you got all four of these correct, then you got an E for essentially correct. If you just had two or three of those, so if you were missing one, then you got a partial correct. And if you only had one of those items, then you got incorrect. Or incomplete. Okay. All right. The next question, you actually had to then look on the next page. And so they talked to you about what would be considered a square person, and that's where the arm span equals the height. So in that case, what's happening is let's see, which one was X, of course. So the height is X and the arm span is Y. So in that case, they're saying the Y equals the X. They even wrote it out. Y first is equal to the X. Tall ones means that the Y values are less than the X. They are less than. And the short rectangle, the Y is greater than the height. So this first question then says, which graph, 1 or 2, is most helpful to be able to tell that shape, and you had to explain why. So because of this relationship right here, because when Y equals X, you can tell what's happening. So then when you have these two graphs, this one has the prediction line of 11.74 plus 0.82x, okay? So this one had that prediction line, but this one was the line y equals x. So of course then, this one is the one that helps with the square and rectangular because you can see which values fell on the line. So your answer has to be graph 2 is the best one to determine the difference between square, tall, and short, rectangular. And the reason is because that allows you to see if the arm span equals the height, is less than the height, or is greater than the height. So let's take a look at how they put that actually in the grading guidelines. So the way that they wrote up their ideal answer is they said this, graph 2 is the one that is most helpful because you can see, there it is, if it is equal to, greater than, or less than. Okay, so that's what they said. Let's see how the people would grade you based on that. All right. So in order to get essentially correct, you had to all four of these things. You had to say graph 2 is the reason, and you had to say because with that you can tell if the y equals x or if the arm span equals it. And because that is the points on the line. See, so you had to make this connection. The points on the line are the square ones. You then can tell if they are the tall rectangle ones, okay? The tall rectangle ones, because they would be the ones that are below the line, okay? So let's see. Let's go back and look at that. So if you're taking a look at this, the tall rectangular one is where the y is less than the height. So if you looked at that on the picture, then that's going to be these ones here that are where the arm span is below the height. Y's less than X down here. So we can also kind of fill in the table as we go along. And so you can see the square one, there were 3 that were on the line. For the tall ones, there were these 4 dots that were below the line. Okay, and then let's do this other color, purple. For short rectangle is the arm span is greater than. So you would have to describe that in your guidelines. The short rectangle shapes are represented by the points above the line. Okay, so this is a big one right here. Okay, having to talk about how you would know which is which. Let me see here. In their little ideal thing, yeah, they did. They said points above the line, points on the line, and points below the line. So you did have to include that. See, you can't just make an assumption that they know what you're talking about. It's like you have to prove your thoughts to get credit. All right, so whenever we take a look at those ones that are above the line, of course, that's these ones here, and I think there were 5 of those. So that's why then this is 5. So let's finish up the credit on this. You had to do all of this description. So I'm worried that you might not have been thorough enough on your description explaining on the line, above the line, and below the line. And then these parts 3 and 4 can kind of go together. You have to then just say there were 3 in the first, 4 in the second, and 5 in the third, okay, to correctly count those. All right, if you got all of those 4 sections, and what happens is if you just reported them in the table, that counts for this part 3 and 4 together. So if you want to essentially correct, then you did a really good description. If you got an E, you got a good description of the second section. You got partially if you only did 2 out of those 2 or 3 out of those 4 components. So if you don't think you did a strong enough description of how you make that choice, then you would have gotten a partially correct instead of the full essentially correct. If you only had one of those kinds of things, you just said choose graph 2 and you didn't explain why or anything related to that, you got it incomplete. All right, so that's the second part. Now let's go to the final section. The final section is use the best model for prediction and calculate the arm span for the height of 61 inches. Okay, so they said use the best model for prediction. So that means use this. Okay, so in order to get credit for this, you had to show the work, you had to show the equation, you had to show plugging 61 in, and then you had to give your answer, and your answer had to have the units inches attached to it for context. So let's see here. Here's how this looked in the grading guidelines. You had to have the correct formula, inserting 61, computed the correct value right here, and giving the answer as inches. Units had to be there. Context, context, context. All right, so if you did all of those, you got 3. If you didn't put inches on there, you went down to a P just because you didn't write the context, okay? So we're playing this game of, proving that you know what you're doing. If all you wrote down was the answer, which was a 62 point something, then you just had one item and you got 0 credit for that. So see, all right, let's see how many points you would have gotten total. 4 is the most you can get, and you did that if you did all 3 of these were E's. If you had 2 E's and a P, you got partially, and then there were several different ways you can just get 2 points. 2 E's and an I, E, and 2 P's, and then one part is E, and then EPI also counts as 2 points, and PPP also counts as 2 points, okay? You get 1 point if you had an E and 2 I's. If you had 2 P's and an I, you also get 1 point. Otherwise, you get 0 points. Okay, so you need to see what you got 4 down to 3 and see if we can't start improving on being thorough so we get all of those points. All right, let's do one more, number 19 or page 19. Scoot on over there to this one. This one is where it's talking and asking you to, and we've got this situation with these wolves in North America, and we're talking about their length in meters and their weight in kilograms of these wolves. Okay, so remember, in keeping in line, we know we're going to want to be talking context as we go through the answers on this. So what does it mean to say positive? And then what does it mean to say linear? And what does it mean to stay strong? Keep in mind, part B is asking you to interpret the slope. Okay, so that will be using our little phrase. But let's go on and look at the grading guidelines because they were really clear on what they accepted and what they did not accept for these 3 words. So let's take a look at that. So for positive, here's what you had to do to get essentially correct. You had to give a correct description of positive, linear, and the strength and context. So you had to do all 4 of those things to get an E. But here's the things that they accepted. They were very clear on the training that they gave the AP graders. Here we go. Here are acceptable responses for positive. Things such as the length increases, so does the weight. Okay, so see, that's giving you context, and it's telling you as one of them goes up, the other one goes up. The longer wolves weigh more. Points on the graph go up as you move from left to right. Now, I don't like that one as much because it doesn't have context, okay? But maybe you would get to context a little bit later. All right, here's something that's unacceptable. As the length goes up, just saying the weight changes. That's not describing positive because you're not saying how it changes. You cannot say both length and weight get bigger. Because what's happened, to correctly describe this positive, one is increasing as the other one is increasing. And that's how it is clarified up there. You can't say the correlation is greater than 0. Interesting. Can't say just that the correlation is greater than 0. Okay, so say if you gave something along those lines for positive. All right, next, let's talk about how you would describe linear relationship. Here are the ones that are acceptable. The points generally follow a straight line. You can say that. The relationship between X and Y, or it would be even better yet if you said between length and weight, is straight. The length and weight have a constant slope, which you may or may not think about that. Okay. All right, here are unacceptable. You cannot just say the points all line up because that is like saying, that could be meaning they're all exactly in a straight line, which this linear relationship doesn't mean they're all a perfectly straight line. They're just increasing in that linear pattern. All right, you can draw a straight line through them. Interesting. They didn't like that, saying you can draw a straight line through it. I guess because, you can have this right here, and you can draw a straight line through that too. So really, what is that saying? Just saying there is a positive correlation does not make it a line, okay? Because I could have data like this, and I could say that's a positive correlation. It would give me a positive R value, but that's not a line. Every increase in X yields a 35.02 increase in Y. So what this is doing is it's getting to the direction of describing slope, but it's not quite there either. So they didn't like that. Although perhaps I wonder if you said there's a predicted increase. I don't know because it says they have a constant slope, and all you were doing is being a little bit more specific here. Perhaps if you had said, it's has, I don't know. So there you go. I couldn't tell you. I just am reading what they have here. All right, the third descriptor, strength, the strength, okay? So that is measuring how closely the data points are to the line. So here are acceptable answers. The observed values are close to the predicted. Observed values are close to the predicted. Or you could say the actual are close to predicted. Okay. Here they say deviations from the line are small. Deviations from that. So, you could probably say the actual data is really close to the prediction line. Wow, they accepted you saying the correlation coefficient is close to 1. Interesting, because they didn't accept you just saying something about for positive. They did not accept you saying the correlation is greater than 0. Okay, so there you go. And then examples of unacceptable. All the points are close together. Okay, so that's not okay because all the points, like this picture shows here, all the points being close together, you can have this right there. That doesn't mean that it's a strong correlation around this line. The scatter plots are clustered together. So see, they're not liking saying that the points are close together. They're talking about the relationship from the points to the line. Relationship of the points to the line. And interesting. They Okay, saying there is a high positive correlation, I guess, wasn't specific enough for it to be close. Say you had to say close to 1. Wow. So they were very particular about what they accepted. All right. And then, of course, you had to say length and weight in there somewhere. You could use meters to kilograms to express that. Sketching a graph to clarify is okay, but a sketch alone cannot satisfy the component. All right, so you want to see if you got all 4 of those items correct. If you just got 3 out of those 4, you got a P. And if you only got 2 out of those items or 1 item, you got an I for incorrect. All right, the next one is the description of the slope. For every 1 increase in the x, which is, what is our x on these ones? The weight, or no, the length is the x. Okay, so for every 1 increase in the length, the predicted weight increases 35.02. That satisfies all the thing. The correct value of 35.02. The interpretation includes that an increase of a specified amount of weight. So for every 1 pound, I guess maybe we need to say for one, for each unit increase in length. So for every 1 meter, so for every 1 meter increase in the length, the predicted weight increases 35.02 kilograms, or whatever that was, okay? All right, so you had to include for every 1 meter increase in the length, the predicted. All right, so to get credit for that, for an E, you had to have all 3 components. For partially correct, you had to have 2 of those 3, and I if you did not do that. If you happened to, okay, so we'll just go on. We'll just go with that. And then the last question was correct computation given this residual. So take a look at what's happening here. Here's what you would have been expected to do. 1 wolf with a length of 1.4. So that's saying your x is 1.4. Has a residual of negative 9.67. And so then you can use this. So you can use the predicted y equals your negative 16.46 plus the 35.02 and plug in your 1.4. Okay, and then that's how you can get that predicted Y value of whatever that came out to be, 20, or wait, I don't know what that. So the predicted Y value, I don't have that written here. So whatever that predicted is. Okay, so you had to give that predicted first, and then after you did that, you had to continue and do the residual. You know, we know that the residual equals the actual minus this predicted, whatever that you computed it to be. And so then you added that over, and your final answer was 22.9 kilograms. Okay. To get the full credit, you had to have the correct computation of the predicted. Okay, so there's what that predicted was 32.568. So that came over here was 32.568. So they had to see this computation, then they had to see you plugging this in to then get the actual weight of 22.9. If, say, you had done this, but you just like subtracted or added or subtracted, did some algebra wrong, then you get partially correct. Okay. But if you have the actual weight, but you do not give sufficient information to determine how it was calculated, so maybe you had the predicted, okay, but you didn't then show calculation for your actual, you're getting your partial also. If you don't have either of those, just I. All right, so you can see here that what was enough to satisfy the various arithmetic components. And so did you get 3 E's? You got a score for 2 E's and a P, and so on. Okay, so we want to see that you are getting all of those as close to 4 points as possible. 3 and 4 points is very solid. You're on track to get a 4 or a 5. If you're consistently getting 2s, then you might be getting a 3, and depending on then how well you do on your multiple choice will determine how well you do on that final score. All right, so there's how you did those 2 free response questions on 10 and 11 and 19.